Right. Hi. Thank you for staying around to the last session. I assume, genuinely, I thought there would be 4 people in the audience, so I'm really happy to see everyone here. I'm going to be talking about a model for creativity. This is a joint work with VC, who's sitting over there in the beautiful blue jacket. Okay, so why am I talking about creativity? I don't think I need to convince anyone here that creativity is important, but I've gotten a bunch of quotes from famous people who do believe that it's important. And I'm not going to read them all out, but I do want to read out this one, which I think might resonate with people here, especially as it pertains to generative AI. So it's by Edward de Bono. He's a creativity researcher, and he says, "There is no doubt that creativity is the most important human resource of all. Without creativity, there would be no progress, and we would be forever repeating the same patterns." So creativity is important. It's important to study. And maybe the most fundamental question we could ask is, what is the underlying process behind creativity? So can we describe the process, the underlying process behind creativity? And interestingly, there's been decades of research on creativity, thousands of articles, and these mechanisms are still not well understood. Right? So this is basically paraphrasing of a quote from a paper by some well-known creativity researchers from last year. And our goal is quite ambitious here, but we propose a mathematical model of the creative process. And if we can have this rigorous, kind of very general model of the creative process, that allows us to do quite a lot of things, and I want to focus on 2 things. The first thing is there's been a lot of literature on how to improve creativity. We call these things interventions that improve people's creativity. And this model allows us to explain them. And another nice thing is if we believe this model and we understand that this is the process, we can design new interventions for boosting creativity. So before getting into the model, let's just define creativity. And most scholars agree that an idea or a solution or something is creative if it is novel and useful. So those are basically the 2 things that an idea, a solution, whatever it is, has to be a picture. To be creative, it has to be new and useful. And mostly in the model, but basically, generally, we're going to focus on novelty. And the main reason is that scholars generally agree, pretty much every scholar that adopts this definition that says creativity is novel and useful, which is most of them, they agree that novelty is the more important component. So it kind of suffices to focus on novelty. We could also mathematically kind of prove that novelty is more important than usefulness, but I'm not going to do that here. And additionally, measures of novelty. So when you measure creativity, typically the way you do it is in a measure that kind of intuitively maps onto novelty. And we find that this actually correlates with what humans call creativity really well. So just measuring the novelty in some sense actually maps really accurately to creativity. Given though that, we're still going to validate the second point. We're still going to look at usefulness a little bit. Okay, so the general inspiration for our model is a semantic network. A semantic network is basically a network that of connections between words in the brain. There's a bunch of different models, but I think this explains it pretty well. We adapted this from a Q-response experiment, which basically is, I give you the word light, you give me the first word you think of. As you can see, 37% of the people, when you say light, they're going to say dark. 21% are going to say bulb, 5% are going to say bright, and so on. Right? And then you give them the word dark, and then you see that 43% give the word light, and 21% give the word night, and so on. And you can kind of see that you can kind of take a walk on this network, right? You think of light, and then the next concept you think of is it might be dark, and then if you keep on going, you might think of night, and you might think of day, and you might go back to light, and so on, right? So this is the general idea. This is the inspiration for the creative network. And in the creative network, we just, in some sense, have basically generalized that idea. So instead of just words, we're going to have concepts. And concept is anything, any abstract concept that you would like to think of. It could be a word, it could be a phrase, it could be a use, it could be an idea for a picture. It's a very general model. And these concepts are connected by edges, right? So we view this as a graph. They're connected by directed edges. I don't have all the edges here. You can view this as a complete graph. I like to view it as a complete graph where every edge has some probability, even though it could be almost zero. You don't have to. And what is a creative concept here? We just define it as something that, intuitively is something that you're unlikely to get to. So if it's a concept that no one has ever thought of before, you're unlikely to get to it if you're just thinking naturally, and that means it's creative. So it's a bit simplistic, but I think it captures most, if you think about it for a second, it kind of captures the intuition of what it means for something to be creative. You're unlikely to find it. You're unlikely to come across it. Right? And basically the way it looks, like zooming in, you have these weights on these edges, and all this means is if you start at the starting node, you're 6 times, right? If the weight of this edge is 6 and the weight of the edge to B is 1, all this means is you're 6 times more likely to go to A from the starting node than to B. So a little bit more formally, the creative network is the following. There are nodes, and the nodes represent concepts, any concept that you like, whatever creative framework you're in, whatever creative world you're in at this moment. Edges are going to be directed, which means the probability of going from dark to light is not necessarily the same as the probability of going from light to dark. And the weights represent these probabilities. A random walk begins at some starting node. In some cases, this could be predetermined. Like if I tell you, give me a word that you associate with light, the starting node is going to be light. If I say draw a picture, it could be random. The walk terminates when some stopping condition has been met. Again, we want to keep this very general. So the stopping condition could be the first word you think of. It could be, I'm happy with this essay right now. And like I said, a node is creative, a little bit more formal than what I said, if the sum of the weights of the edges going in are below some threshold. So intuitively, if you're unlikely to get there. And then on this creative network, right, we have this random walk. Oh, sorry. And the walk is successful. Random walk is successful if it lands at a creative node. And so you can kind of view this. You start at some node, and then you're going to choose one of these edges with probability proportional to their weights, and you're going to walk to the next node. So you might choose this edge, and then you get to this node, and from here you might choose this edge, and then you've hit your stopping condition, so your walk terminates. In this case, your walk was not successful. You didn't end up in creative. Okay, so given this is the model, and an intervention is anything that tries to increase the probability of the success of a random walk. Anything that basically says, look, do this, and this is going to increase the probability of you ending up at a successful node. It doesn't have to, at a creative node. It doesn't have to be successful. It just has to be something that is an idea that tries to do it. And if you look at the creativity literature, we've looked at a lot of it, not all of it. It's thousands of papers. But you can kind of group all the interventions based on this model into 4 categories. So the first one is constraint focus, where you say, okay, you have to focus on these concepts. You can't go to another concept. There's a specific set of concepts you're constrained to. You can't walk outside it. Another one is a contextual shift, which is basically changing the context you're in, which in our model basically changes the edge weights. Right? So if I tell you, think of a word you associate with light, and we're sitting in this room, you might think projector, you might think dark. If we just came out of a physics lesson, you might be more likely to say photon, right? So I've changed the weights of your semantic network, of your creative network. The third one is emotion modification, which is modifying the emotion, which you could argue is a version of contextual shift, and I won't argue with you because I'm kind of split on whether it is or not, but you could argue it's something different. So emotion modification, if I just tell you, all right, tell you you're now sad, or make you sad, or make you happy, if I say the word light, you're more likely to say dark if you're sad. And the last one is output suppression, which is basically don't give me an output yet, just yet. Wait for a little while, do something else, take a shower or take a walk. Keep thinking about it, and after some time, output. Finish terminate your walk. And intuitively, you can kind of see why this works. I'm just going to show it for contextual shift, but if you look at these edge weights, if I change them and I'm lucky, right, I managed to change them in a good way, you can see that I'm really increasing the probability of hitting the creative, right? Because usually I wouldn't get to this note before the intervention, but suddenly after the intervention, super likely to get it. Right? So that would be the best case scenario. Not every intervention is guaranteed to do that, of course. I might even decrease the probability if I do something bad. Okay, so this is the general model. This is the model. This is what we mean by interventions, right? So we have this network, this creative network. There's random walks on it. We have these interventions, and we want to validate the model. So the way we do that is we test the effect of interventions. We want to see if these interventions actually, we're going to try to take really simple interventions, really basic ones, and see if they improve creativity. And we're going to use two really well-known creative tests. The first one is the AUT, the Alternative Uses Task, which you may have heard of. Give me some uses for the word pencil. So generate a list of alternate uses for an item. And the second one is a newer one, which is the verb generation task, which is I give you a noun, give me a verb you associate with this noun. And both of these have been shown to, in some sense, you can quantify creativity well using these tests. And our measure of creativity, we operationalize creativity as the semantic distance between the cue and the response. And we use this as it's been shown to actually correlate with creativity really well. And as an example, the semantic distance between the word shoe and the word wear is 45.2, and the semantic distance between shoe and magnetize is 103.6. So you can say, if I give you the word shoe and I say, give me a verb, you say magnetize, that's a more creative response than the response wear. So we applied the AUT to ChatGPT-4, and we used Amazon Mechanical Turk to also assess the relevance, which I don't want to get into in this talk. I don't have that much time, but we did look at that. And we applied the VGT to ChatGPT-4, Llama, and to human subjects on Amazon Mechanical Turk. And our interventions are no intervention. We ask it to be creative. We ask it to restrict it to a certain number of words, say alliteration. So if I give you the word light, give me a verb that starts with L. Space elephant's kind of this random thing. We just say, look, space elephant, think of a space elephant and give me an answer. This is from an intervention in the literature. Another one is, think of an unusual environment in which you find this noun and then answer. And the last one is only for the VGT. Instead of giving me the first verb you think of 5 verbs and just give me the fifth. And that's kind of output suppression, right? So don't answer, don't answer, don't answer, don't answer, now answer. And the way we did it is actually really simple. It basically looks like this. Just give it a prompt, give me 10 creative uses for a warehouse using 2 words each. Each use must be an alliteration. Then we get these 10 words, and we compute the 10 phrases, and we compute the semantic distance. A little bit about the results. There's a bunch of columns you can look at. Choose whichever column you want to. It doesn't really make any difference. They all show the same result. I like the 90th percentile because if you think about creativity, you're usually going to think about the more creative ones, but any of them will do. And you can see how much more creative the different prompts are, right? So if there's no intervention, the median is 67, the distance is 67, and it goes up, and you can see that statistically there is a big difference, right? You can see the improvement. But for me, the really important thing, the really interesting result is the comparison with creative. Right? So the difference between when I tell it, give me 10 creative uses for this item, versus when I say, think of an unusual environment and then give me 10 uses for that in that environment, this is statistically significantly more creative than if I just tell it to be creative. So this is for AUT. We get similar for the alternative uses tests. We get similar results with VGT. I think these are even more striking. So verb generation, when I tell ChatGPT be creative, I don't show the difference between creative and the others on this chart, but I think everyone here knows statistics well enough to kind of be able to see, yeah, this is good, right? So the difference between when I tell it to be creative to when it does unusual environment or uses a creative alliteration or thinks of a space elephant, there's a clear increase in creativity with these interventions. And finally, we get similar, slightly different, but similar results when we do this on human subjects. Okay, so in conclusion, we propose a mathematical model for the creative process. We use this model to explain how interventions to improve creativity work and why they work. And then this allows us to propose these novel interventions. And we test these we demonstrate that these interventions are indeed effective, and they're actually surprisingly ubiquitously effective on a bunch of GPT models, a bunch of LLMs, and on human subjects. So thank you for listening.
All right, we'll start over here with our first question.
Thank you. First of all, go Boilermakers, please excuse the dumb question from Purdue alumni. I have a couple of questions about the model. The first one, without usefulness, how can we distinguish creativity with craziness? Second question is, how can we construct the network when we do not know what are the possible nodes in the network? And the third one is kind of a comment about that. When we go to the creative destination with multiple steps, it would be less creative. It goes directly to the creative node, it could be more creative. So, yeah.
Okay, so 3 questions. First one about that. First one is, okay, so what you're saying makes, the question was novelty versus usefulness, right? If it's just novel, but it's not useful, you said it's crazy, which is fair, but I could talk to you and explain to you, but the easiest answer is there has been a lot of literature, and the literature agrees on this, right? So the literature agrees that novelty is a good enough measure. That said, it is a fair point, and I think it's a fairer point if you say, okay, if you're trying to train ChatGPT to be creative in order to beat this test, yeah, then it's going to beat the test and it's going to give you some stupid answers. But typically, when I ask ChatGPT to give me a verb for shoe, it's not going to give me something ridiculous. If you look at the actual answers, right? If you look back at these answers, they all make sense, right? So we don't really have to worry about that. That said, like I said, we did actually take care of that. We asked people on MTurk, which answers are not relevant, and we got rid of them. Second question, I don't think it matters how you get to a creative node. Personally, if you disagree, that's fine. If you paint a painting and it's creative and it changes the world, that's great. I don't care how you got there, right? Personally, or if you give me a good answer, to me it doesn't matter. I don't think it's the node itself, the concept, is not more creative because you got there. That's the way I see it. I don't think it's. You could say the process is more creative. A lot of things that, but I don't think the node is more creative. And your third question, I forgot. Sorry.
The speed of the to the destination. How many steps we take to the
Oh yeah. So that's the third one. I answered that. What was the second one? Sorry.
second one? How can we construct the network when
Oh.
we don't know the node?
Yeah, so you don't construct a network. This is not constructive. This is an abstract framework for conceptualizing how creativity works. And I argue this is how creativity works. And this is not how ChatGPT works, by the way, right? ChatGPT creates the next word, just guesses the next word. But I say this is a framework in which you can study creativity. And it seems to model the way, at least for me, I believe that this is how my creative process works.
All right, thank you so much. We don't have time for any more questions.